Okay, in this question we have a function that's given here. It's a cubic polynomial, and they're asking us first in part A to find the average rate of change for this function on the interval 0, 3. So from x equals 0 to x equals 3. This means the average rate of change will be f of 3 minus f of 0 over 3 minus 0. This is the formula for the average rate of change from A to B. You do f of B minus f of A over B minus A. So f of 3, so put here 3. What is f of 3? Is, let's use a calculator to do it. Even though we can do it by hand, but for this it's faster to use a calculator. So 4 times 3 cube minus 5 times 3 plus 1 equals 94. So it's 94 minus f of 0. Now f of 0 is easy because it will cancel this and this. It will get only 1. F of 0 is just 1. Over 3 minus 0 is 3. So this is 93 over 3. 93 over 3 is 31. So the average rate of change between the 2 points is 31 between 0 and 3. Calculate the derivative of the function f prime of x. This also is simple because the function is a simple function. So its derivative is just, you use the power rule. So for x cubed, you bring the 3 down, it will be 12, and then subtract 1 from the power. It will be 12x squared minus derivative of 5x is 5, and derivative of 1 is 0. I'm looking at the 1 here, yeah? And so the answer is 12x squared minus 5. This is the derivative. Now find the instantaneous rate of change. This means f prime again of f at x equals 2. So it means just evaluate the derivative at 2. The derivative, you already found the general formula here. So you'll say f prime at 2. I will substitute 2 in the formula. 12 times 2 squared minus 5. If you put the 2 in this formula for x, and you'll get 12 times 4 is 48 minus 5 is 43. Okay, so you can check 12 times 2 squared minus 5. Yes, 43. Find the equation of the tangent line to the graph of f at x equal 2. Remember the equation of the tangent line, y minus f of 2 equals f prime at 2 times x minus 2. Always it will be like this. The number that we have here is the slope m, and this is the point a, and this will be f of a. Always for any graph, this is how you get the tangent line. But we calculated all of these before. So y minus f of 2, notice that we did it. F of 2 is not computed here. No, f prime of 2 is computed. Yeah, 43. But f of 2 we can compute it. Just put 2 instead. And we actually can do it on the calculator just by replacing the 3 that we did before by 2. So this will be 23. F of 2, if you replace 2, you'll get 23. So y minus 23 equals, the derivative is 43 into x minus 2. And you can just make it look better by putting everything on the other side. So this will be 43x minus 43 times 2 is 86. And this one, when it comes to this side, it will be plus 23. So minus 86 plus 23, it will be 43x minus, that will be what, 53? 53 or 63? I think 63. 63, yeah. If you get 23 minus 86, negative 63. Perfect. So this is, we claim that this will be the equation of the tangent line, y equal 43x minus 63. I'll write it here in a small place so you can see it clear. Y equals 43x minus 63. This is the equation of the tangent line, so the solution to D. And we can check all of this on a graphing calculator, like it's asking us, check your answers on a graphing calculator. We can check all of it. So first we draw the graph of it. It's 4x cubed minus 5x. So let's take this out and do the question. Y equals 4x to the power 3, 4x cubed minus 5x plus 1. And so the graph looks like this. This is the graph of a cubic polynomial. And what did we do? We wanted to find the equation of the tangent line at the point 2. So first, the point 2, if you draw the point 2 and its image, what is f of 2? We computed f of 2 was 23. So 2 comma 23, label it. It is yes on the graph. Oh, it's not on the graph. So 4x cubed minus 5x, plus 1. Here it's plus 1. Yeah. And it is, yeah, on the graph. And it's the graph of a cubic function. It always looks like this, or it has just one turn. Okay, or two turns. It's only one of these. So at the point 223, we want to compute the tangent line. So what did we find? Let's check that it will be the right one. Y equals 43x minus 63. And let's take this out and check here. Yeah, it looks perfect. It is the right tangent line. It touches at the point and it's tangent there. Okay, so for example, if you made the mistake and put it as 62 and then you zoom in, you'll see that it doesn't touch. It must be what you found, 63. At 63, yes, like this. So you remember it was from the point here, look, you'll do y minus the y coordinate 23 equals slope, leave a place for it, and then put x minus the x coordinate of the point is 2. And all what you have to do here is put the derivative at 2. And the derivative you get from here, what is the derivative? 12x squared. So you can say 12 times x squared minus 5. And then they're asking you at a specific point, 2. And that's where you get the tangent line correctly. And I will tell you quickly, if you want to do it in general, and you do y minus f of a equals the slope into x minus a. So let's do any a. So here y minus f of a, you will put a inside this formula. So you'll get 4a cubed, 4a to the power 3, and then minus 5a plus 1. That is f of a. And then the derivative at a is 12 times a squared. So 12 times a squared minus 5. Notice now, I will show you, and take this tangent line that we found out. The tangent line that we found before, the green one, out, and this one. Okay, so let's see. As a moves, we got all of them. These are all the tangent lines at all the points for our graph. So we did it in general, the formula y minus f of a, just replace a inside the formula here, and equals the slope is something you compute from here, 12x squared minus 5. Then you replace a there, times x minus a. And then if you choose any a, for example, they told us to do it at 2 in the exercise we solved before. So at 2, you'll get the right tangent line. But this way you get all of the possibilities. If they ask you find the tangent line at 0, for example, at the point 0 here. So you'll say y minus, the y coordinate of 0 is what? Is 1. Y minus 1 equals the slope at 0 times x minus 0. But the slope at 0 is what? It's 12 times 0 squared. So you replace it in the slope. 12x squared minus 5. So if you do 12 0 squared minus 5, and you see you will get the tangent line that passes through this, which you can also get from ours here by putting a equals 0. Here, you get it on top of it. So it's nice to practice with this. That's why I show it to you a lot of times, is to get all the tangent lines to the graph. Once you have any graph that you know how to graph it, then graph all the tangent lines and find all the slopes at once. That will make you understand the question much better. And I will stop here.